Hey everybody, want to give you the demonstration that I gave to the classes today for you that are remote. Did a little demonstrations, did some practical stuff here, worked with a density formula triangle. So you're going to get that information and you're going to get it just like you were sitting in class, because actually right now you're sitting in one of the desks in class. Actually you're on it, piled up on about 15 books. But that doesn't have anything to do with what we're doing. Here's what we are doing. We are looking at how to calculate density, how to, in this formula, be able to find mass or volume or density just given that formula. Easiest way that I've found to do it is this handy little tool right here called the formula triangle. And what we're going to do is we're going to take the numbers, or take these properties right here, and we're going to stick them into the formula triangle so we know how to use them in just a second when we need to, when we get the actual numbers, and how you know what you're working with out of a word problem, or in something like this where we're actually measuring and getting those numbers for ourselves. So since mass is on top of this line here, we're going to move it over here and we're going to put it on top of the line there. Since volume is below the line, we're going to put volume below the line there. And since density is off to the side and we've got an empty spot, that's where we're going to put density right there. So you know from math that if you are seeing this mass on the top and volume on the bottom, you know that you're going to divide the top by the number that's on the bottom. So what we do is, when we get to our formula triangle, if you're given a mass in a formula, you are going to divide the mass by whichever number you get on the bottom, either the density or the formula. So how do you know that you have in a word problem you've got a mass? You're going to know that it's a mass because how do you look at the measurement of mass? You look at this. You look at grams. So if you've got grams in a formula, you know you've got a mass. Moving on to density, you've probably seen this the last couple of days in a video or two, the one about density. The label for density is grams per centimeter squared. So if you get that label, you know that you have a figure that you're going to plug into the bottom of your formula triangle. The label that you get for volume is milliliters, ml. So in a word problem, if you get milliliters, you know you put that in the bottom of the triangle as well. So we know that if we get a mass, let's just say in a word problem that you are given something that has the label milliliters and you get something that has the label grams, you know you've got a mass and you've got a volume. So you divide your mass by your volume, and what you're solving for is the density. If you're reading a word problem and you get something in grams and you get something in grams per centimeter squared, you know you're trying to solve for the volume. Thirdly, with the formula triangle, if you don't have something that has a label grams, but you've got a label for grams per centimeter cubed, I've said squared a couple of times, it's cubed, grams per centimeter cubed, and you get milliliters, what you're going to do there is you are going to multiply those two numbers to get your mass. So that's how the formula triangle works. When we get to physics, we have a couple of more formula triangles, but that's the one that we'll use to calculate density. Now on to the demonstration of actually calculating density of an irregularly shaped object. Here we have a rock. This is our irregularly shaped object. The first thing we have to do is we have to come up with one of these figures. So with the triple beam balance, we're going to put the rock on the triple beam balance and we're going to measure it out, and I've already done this 3 times today, so I know about where it will go, and it should be right around 36. Let's say it's gained a little weight. It's kind of like me. So the rock is 36 grams. So you've got a mass of 36 grams. So you know which mathematical calculation you're going to do to find the density. You're going to do division, because this is the mass. Next, what we're going to do is we're going to look for the volume. The way that we measure volume is we use the graduated cylinder. In the graduated cylinder, I have 300 milliliters of water. So when I put this in here, just like when you get into a bathtub, the water level goes up. When I drop this into the graduated cylinder, the water is going to be displaced and the water level of the graduated cylinder is going to go up. That's going to give us the volume of the rock. The difference between where the water level is now and where the water level rises to, that's the volume of the rock. So then we will have the second number that we can plug in to our formula triangle to figure out the density of this rock. So we start with 300, it was 300, evaporation happened. So we'll just call it 300. So it's actually 280. I don't know how the water level went down. It's not that hot in here. It's usually pretty cold. When you get here to school, you'll figure out that I'm half polar bear. That's why it's always so cold in my room. Anyway, 280 milliliters of water. When I drop the rock in, it's going to displace the water, and the water level goes up to 320. So 320 minus 280, if my math is correct, that's 40 milliliters of water. So the volume of the, isn't that right? Yeah, that's right. The volume of the rock is 40 milliliters. So now we've got a volume of 40 milliliters. We have our mass of 37 grams. So we would divide that, our 37 grams, by our 40 milliliters of water, and that's going to give us our density of whatever that number would be. I don't have a calculator right here. I'll just let you work that out at the house. That's what we have there. Okay, so that's how you use a density triangle, or a density formula triangle, and how you use water displacement to figure out the density of an irregularly shaped object. In one of the things that you looked at, I think it was yesterday, you had a scenario where you were given 3 liquids. You had to look up the density of the 3 liquids. You had to look up motor oil, glycerin, and water. And then in your head, you were going to use those 3 densities and see how they would stack up if you poured all 3 of those liquids into a beaker. Well, here it actually is. You have motor oil on the top. It was the less dense. And I know it's kind of hard to see because the glycerin and the water are the same color. But if I turn this to the side, you can kind of see the line between the water and the glycerin. You can kind of see it there really well. So glycerin was the most dense. It's at the bottom, followed by the water and the motor oil, which was the less dense, and it's on top. So that's that. The other thing that we did today was we did a little demonstration for viscosity, where we took those same 3 liquids, motor oil, glycerin, and water, and what we did is we took these 3 marbles and we timed how long it took for the marble to drop, from the time it takes me to drop the marble for it to go down and hit the bottom of the graduated cylinders here. So we had timers lined up in the class, and it wasn't a race. We did them one at a time. And what we did was we started with the motor oil, just because it was on top in our density demonstration. We did the motor oil first. And we tried to make a comparison between density and viscosity. The cohesive forces have nothing to do with the density. So you might think that because motor oil was the less dense, that it would be that the marble might drop through the motor oil faster than the water and faster than the glycerin based on density. But like I said a second ago, density and viscosity, but cohesive forces have very little to do with each other. So what I want you to do is turn on the stopwatch on your phone or whatever. Don't act like you don't have your phone sitting next to you. But you're going to turn on your stopwatch on your phone. I'm going to say 3, 2, 1, and I'm going to drop the marble. And I'll tell you when to stop it. And that's the time it takes for the marble to drop through the motor oil. And I think you can see it from where you are. So here we go. 3, get your stopwatch ready. Pause it if you need to. I'll wait. Good? Okay. Here we go. 3, 2, 1, drop. And you can see the marble going down through the oil. And Stop. It just hit the bottom. Okay, that's the motor oil. Low density has nothing to do with cohesive forces and viscosity. This is let's do the water next. Here's the water, because it was the second most dense thing in our little beaker experiment. The water and the viscosity. Get your stopwatches ready. I'll wait. Okay, good. 3, 2, 1, go. And you saw that it dropped pretty quick. So density, cohesive forces, and viscosity, not a whole lot going on there. Last one is the glycerin. I'm going to drop it. You do your stopwatch trick. Here we go with the marble and the glycerin. 3, 2, 1, go. It's not there yet. You might think this is slow motion, but it's not. It's not even there yet. Still going through the glycerin. It's not there yet. And stop. So that is one way that you can look at viscosity, dropping an object into a liquid and seeing how viscous it is, whether it's a high viscosity, which means that something's going to travel through it really slow. If it's poured out on a surface, is going to travel really slow, versus a low viscosity liquid like water, where if you drop the marble in it, you can't even time it because it goes from top to bottom so fast. Or if you were to pour that out, it's just going to go really quickly because it has low cohesive forces, low viscosity, but it has a high flow rate. So that's the two examples that we looked at in class today. The two demonstrations, probably the same that I did in all three of my classes today. So hopefully this helps you a little bit, give you something to look at. I'm going to let you just watch that as many times as you want to. Enjoy. Hope to see y'all soon. Bye.